Hi team, now we're ready for section 2.2, fitting lines to data points or modeling linear equations. One of the things that students often ask is, how did they know this equation represents the population here or the profit or whatever? How do they come up with these equations? Oftentimes they just have months worth or years worth of data that they graph in what's called a scatter plot. Now, a scatter plot is a graph that shows the relationship between two quantitative variables. Remember, quantitative just means it's numerical, and you could take an average and it would actually mean something, right? So between two quantitative variables where each point represents an individual or just one piece of information, February's temperature, March temperature, every dot, that's a scatter plot. Now, a scatter plot, which is also known as a scatter diagram, uses what we call discrete data points, meaning we could probably list all the little, different values that are for each point. A linear equation, for example, represents continuous data. Continuous just means it's smooth with no gaps. So it could be linear, but it could also be a curve. So what do? They take all of these points in a scatter plot and they look to see what kind of shape does that make? Is it close to a linear shape or a quadratic shape or a cubic shape? What kind of shape does it have? And it does what's called a regression. Like for lines, it would be a linear regression. And what that does is it analyzes the strength and the characteristic, of course, the characteristic meaning, is it linear, is it quadratic, etc., of that relationship of the two quantitative variables. And it comes up with an equation either exactly on top of those points or approximately. So that's why this type of relationship can be either approximate or exact. So here are some examples of scatter plots. This particular scatter plot is an exact linear because we can draw a line with the exact same slope no matter which 2 points that we choose. I mean, they fall exactly on a line. If one point was off, it would be almost exact, but almost exact is not exact. In 2, it kind of looks linear. We could probably create a line that's close to those points, but it's not going to be exact. So this would be an approximate linear regression. For number 3, well, that guy doesn't look linear at all. It could be maybe an upside down absolute value. It could also be, like a parabola, but we would basically say non-linear. This would be more of a quadratic regression. 2 terms that are good to know. One is called interpolation, and that's when you're estimating values within a given data points. Okay, so in between, within, in, interpolation. So if we're looking at example 3, notice our data points that were given are 1, 3, 5, 7, 9. So if I were to estimate f of 4, that 4 is inside the data points that were given. So that would be an interpolation. Extrapolation is estimating values outside the given data points. So think of external. Within is internal, outside external. So again, if we started at point 1 and had points through 9, if I try to estimate the function value at 12, then that's outside the data points that were given. So you have to be careful. This one is generally okay. This one, you have to caution. Okay, I caution you on going outside.